Now let's take a look at the concepts of complex numbers. What are complex numbers? Well, complex numbers are the biggest number system we have in the mathematics. So far up to this point, we've been working with real numbers, right? Obviously, the real number system. So we know about quite a bit about that already, right? That includes what square roots, cube roots, fourth roots, fractions, decimals, right? Integers, right? Basically, all the numbers we've seen up to this point. But complex numbers is even bigger than that because complex numbers are defined using a different component called an imaginary component. All right. So let's take a look at the standard form for a complex number. First, let's go define a complex number. Let me say that a complex number. I'll just say the standard form. The standard form of a complex number is written as a plus b I. All right. Let's talk about these: the a, the b, and the I. All right. Now the a and the b are real numbers, so these are real numbers. So these could be, again, fractions, decimals, square roots, cube roots, right? All the numbers we've been working with are the real numbers, a and b, right? So a and b are real numbers. Now what about the I? The I is the imaginary number, all right? So now the I is defined as the square root of -1. So this is the definition of I, all right? So a complex number is written in the form of a plus bi, the standard form, right? And then a and b are real numbers, and I is represented as the square root of -1. So remember when we took the square roots of negative numbers and the calculator gave us an error, right? Well, that turned out to be a complex number, the imaginary number I. All right. So let's talk about how to write these numbers out in more detail. But let's look at some examples first of all. Here are some examples of complex numbers. All right. So for example, 4 plus 3i. All right. So 4 is the real part, 3 is the imaginary part. So this is the real part of the complex number, real portion of the complex number, if you will, and the 3i is the imaginary portion. Oops, imaginary part of the complex number. All right. So another one could be written as 0.75 minus the square root of 2i. All right. So again, the real numbers are 0.75, and b. So my a is 0.75 in this case, right? That's the real part. The imaginary part is the negative root 2i. But the b in this case was going to be what? Negative square root of 2. All right? But let's talk more about this I imaginary number being defined as square root of -1. Now, if I is defined as the square root of -1, so let me say that if I is equal to the square root of -1, then we're going to define I squared as -1 itself. All right? So keep this definition in mind. If you square the imaginary number I, then the answer is going to be -1. So it becomes a real number, -1. All right. So keep this in mind when we do some calculations later on. All right. But let's talk about simplifying square roots of negative numbers. So we talk about what square roots of negative numbers being imaginary, right? So that which is not a real number. So again, you get an error on the calculator when you try to punch this in. All right. So let's talk about simplifying these types of numbers. Well, the key is to write them in terms of I. So here's what I mean by that. Let me go and clear out the screen. Let's say you want to simplify the square root of -4, for example, all right? So the first thing you're going to do is you're going to write that in terms of I by removing this negative sign inside the square root. So in other words, you're going to write this as I on the outside, square root of 4 on the inside, all right? So once we remove this negative sign inside the square root, then what we do is we put an I on the outside to do that, all right? And what's root 4? Root 4 is just 2, so the answer is 2i. In other words, square root of -4 is 2i. All right, it's the imaginary number 2i. Let's try another one. Let's take a look at the square root of -49. All right. Again, first thing we do is write it in terms of I. So I square root of 49, which is what? 7i in this case, right? Because root 49 is 7. Right? So no big deal, as you can see. as we're simplifying these types of numbers. Let's do one more perfect square here. How about the square root of negative 225? Again, that's going to be I radical 225. And what's that on your calculator? Well, 15, right? Root 225 is 15, so 15I. Alright, so no big. Let's try one that's not a perfect square. For example, let's try something like square root of negative 45, for example. Alright, again, first of all, write it in terms of I. So I, so first step in simplifying square roots of negative numbers is write it in terms of I. So I, and then take away the negative sign inside, becomes 45, positive. And then we simplify that, but that's what, 9 times 5. You remember how to simplify square roots. What comes out of it? 3 coming out. All right, so we're going to write this as 3I on the outside and root 5. 5 stays inside. All right, so 3I radical 5. Let's try another one. Let's take a look at something like, how about the square root of negative, let's make it negative 72. All right, negative 72. So that's going to be what? That's going to be I radical 72. So to remove the negative sign inside, put an I in front. Right? That's an I right there. Sorry about that. So then let's simplify this. So this is 36 times 2, right? So therefore, what comes out of the square root? 6 comes out. So it's going to be 6I square root of what? 2. All right. So simplifying square roots of negative numbers, as you can see, is very simple. You simply what? Make it positive inside by putting an I on the outside, right? Signifying that's going to be an imaginary number, and then you finish off simplifying the square root to get the final answer. All right. Let's talk about adding and subtracting these types of complex numbers here, right? So let's go and clear out the screen here. Let's suppose I want you to add the following two complex numbers. Let's go ahead and add something like 7 minus 4i. Let's calculate 7 minus 4i plus negative 11 plus, let's make it 12i. Alright? So how do we add these two complex numbers? Well, as you might imagine, adding this is not hard at all. It's simply combining like terms. So all you do is what? Combine the real parts and combine the imaginary parts together. So in other words, you're going to write this as 7. So first of all, we just dropped the parentheses. 7 minus 4i minus 11 plus 12i. That's 12 there. Sorry about that. 12i. All right? That's a 12 right there. Again, sorry about that. That's an I as well. All right? But again, let me put the like terms there. So 7 minus 11. Again, you don't have to show all these steps on the homework. Just simply do it in your head if you want to. Right? Minus 4i plus 12i. Alright, combine like terms, that's going to be negative 4 is the real part. Imaginary part, positive 8i. Okay, not hard at all. Let's just do a subtraction problem here and move on since it's pretty simple. Just combine like terms. Let's go and try negative 2 plus 9i minus the complex number negative, let's make it negative 11 minus 10i. Alright? So let's go ahead and subtract these two complex numbers. But again, subtracting means what? Combining like terms, but also distributing this negative sign to this complex number. So just bring down the minus 2 plus 9i here. So negative 2 plus 9i. And then we're going to get plus 11, distributing the negative sign, and plus what? Plus 10i. Okay? So combining like terms, negative 2 plus 11 is 9, positive, and 9i plus 10i, just do in your head, 19i. Okay, so subtracting a complex number, one extra step, distributing the negative sign, and adding two complex numbers, just simply combine like terms, and we can definitely do it in our heads and skip these two intermediate steps if you wanted to. Alright, not hard at all. But let's focus on multiplying and dividing complex numbers. That becomes more complicated. Let's go and try this problem here. Let me go and clear out the screen. Let's take a look at this one. Let's take a look at something like, let's say 5i times the complex number. So first complex number is 5i, the imaginary number 5i, times, let's say, negative 2 plus 3i. Alright? So that means what? As you might imagine, we need to distribute the 5i. So let's do that. So 5i times negative 2, negative 10i. Alright? What's 5i times 15i? 3i, excuse me, 15i squared. 15i squared, because I times I is I squared, right? Now remember how we defined I squared earlier, right? let's recall that I squared is equal to what? Negative 1. Let's recall that, right? From earlier, all right? So therefore we can replace I squared with negative 1. So this is negative 10I plus 15 times negative 1. If I do it step by step, and that's going to be negative 10I, all right? What? Minus 15. Minus 15. Now we should write the final answer in standard form, which means what? The real part first and the imaginary part second. So write the final answer as negative 15 minus 10I. That's probably the better way to write the answer then. All right? But either one's fine. All right? So again, distributing, but using the fact that I squared is negative 1. Let's go and try another one. How about something like, let's see here, 1 plus 3I times let's make it 5 minus 2I. Let's go and try that one. Now, as you might imagine, this is the FOIL method, or the distributive property, right? 2 arrows on top, 2 arrows on the bottom to make this multiplication work. So let's do that. So let's distribute the 1. So 1 times 5, 2 arrows on top is 5. 1 times negative 2I is negative 2I. Nothing changed there. Basically, 1 times that is it's itself. But distributing the 3I, we get what? 15I. All right, and the outer there is going to be what? Negative, positive times negative is negative, so negative 6, right? 3 and 2, I what? Squared, because I times I is I squared, right? Again, I squared is what? Negative 1, so we're going to replace this I squared with negative 1. And combine these like terms, that's an I right there, so sorry about that. So we're going to get 5, negative 2I plus 15I is what? Positive 13I, all right? 13I there. And then minus 6 times negative 1, all right? I squared being negative 1. So you can skip this step and say, just basically I squared means what? Negative 1, so change that sign to positive. That's fine too. So in other words, we're going to have 5 plus 13I plus 6. So I could have jumped from negative 6I squared to plus 6 down here and not show this step if you wanted to. It's up to you. The final answer is going to be what? 5 and 6 is 11 plus 13I. All right? So therefore, we get this complex number as the product of these two complex numbers. Let's try another one. Let's take a look at something like the, how about using a formula perhaps, right? Let's look at this one here. How about 7 plus 2I quantity squared. 7 plus 2I quantity squared, right? Again, use that formula of A plus B quantity squared. There's my A, the 7. There's my B, the 2I. So I can write it down. A is going to be 7. B is going to be 2I. Right? So A squared, let's recall that formula. A squared is what? 7 squared, so 49. All right? Plus 2AB, right? 2AB is the middle term. So A times B is what? 14I here. Double it. So what? 28I. All right? So plus 28I. 2AB. All right? Plus what? B squared, right? B squared is going to be what? 2I squared is going to be what? 4I squared. Can we see that? Because you square 2I, you get 4I squared. I squared is I squared, right? So there it is. Again, I squared is what? Negative 1, so you could change that sign to minus 4 if you wanted to, but again, I'm going to show it steps. So 49 plus 28I plus 4 times negative 1. All right? So 49 plus 28I minus 4, as I just talked about. And then 49 minus 4 is what? 45 plus 28I. So solution is that complex number, 45 plus 28I. All right? So not hard at all. We know that formula, that perfect square formula we had, right? Let's write it again here. A plus B quantity squared is what? A squared plus 2AB plus B squared. All right, let's use the other perfect square formula in this problem. Let me go and clear out the screen. Let's try this one. Take a look at 6 minus 7I quantity squared. How about that one? Again, my A is going to be 6. My B is going to be 7I. All right, so therefore A squared is going to be what? 36. All right, A times B is what? 42I, right? 6 times 7I, double it, 84I. So, but what? Minus 2AB, right? Remember the formula again? A minus B quantity squared is what? A squared minus 2AB plus B squared. All right? So 36 minus 84i, oops, sorry about that, sketchpad's acting up a little bit, plus b squared. B squared is going to be a 49i squared. 49i squared. Again, I squared is what? Negative 1, right? This is going to be negative 1 here. I'm going to change that to minus 49 if you don't mind. Skipping that step here, right? If you don't mind here. So 36 here minus 84i minus what? 49, basically, right? Minus 49. So 36 minus 49 is what? Negative 13. Negative 13 minus 84i as our solution. All right? So know the formulas, right? They might come in handy. All right, let's try this one. Let's look at the third formula we had, right? Remember we had this formula as well in the past. Look at 5 plus I times 5 minus I. All right, again, this is of the form A plus B times A minus B, right? Let's recall that formula. Difference of squares, right? A squared minus B squared formula. So again, my A is 5, my B is what? I. So a squared is what? 25, right? Minus b squared, I squared. So 25 minus negative 1, right, for I squared. So 25 plus 1, or just simply 26, if I multiply these two complex numbers together. And notice that if I times them using this formula, look, difference of squares becomes a real number. The imaginary component disappears. Can we see that? So sorry for this extra mark right here, so it shouldn't be there. 25 plus 1. All right, let's go and try another one. How about 3 minus let's make it 5i times 3 plus 5i. All right. Again, I just apply this formula, difference of squares. My a is 3, my b is 5i. So 3 squared is going to be what? 9 minus what? 25, right? B squared, 25 what? I squared, if you apply this formula here, right? So again, 3 squared is 9, 5i squared is 25i squared. This minus sign comes from the formula. All right? So 9, basically 9 what? Plus 25. You want to skip the step of I squared being negative 1, right? So that changes that sign to positive. 34 is the solution there. All right? So no big deal here using the formula, but look at this relationship. If I use this formula again, the imaginary number, the imaginary component disappears. Now, these two numbers, when you multiply them, or not when we multiply them, but these two numbers, if we were to multiply them, becomes a real number, these two imaginary numbers. If two imaginary numbers multiply to a real number, as the case we have here, right, then they are called conjugates of each other. Let me go and define that. So here's what I mean by that. Let me say that the complex conjugate, since we're talking about complex numbers, right, not just square roots that we had earlier, right? So the complex conjugate of a plus bi, so complex conjugate here, is basically what? Just change the sign of the bi, a minus bi. So it's basically that guy, right? Keep in mind that if you times them together, the imaginary component disappears, as we saw in the previous two examples, right? Well, that'll segue us into division. Let's take a look at division here, all right, of complex numbers to wrap things up here, if you will. So let's say we're dividing by just one complex number. Let's say we have something like, for example, let's make it 3 plus 5i divided by, let's say, 2i, all right, divided by 2i. Just one imaginary number here on the bottom. Now, to divide this here, then just sort of like dividing by a square root, where we have to get rid of the square roots on the bottom, right? We have to get rid of complex numbers on the bottom. It's a very similar concept. Now, but let's observe that earlier we had what? I squared being what? Negative 1, right? So if I can just, to get rid of I simply have to get I squared down here to make that happen. Now to get an I squared, I need to times the bottom by I. But I can't do that without doing the same thing to the top. Otherwise, it's changing the problem. So, in other words, the concept of dividing by just one imaginary number is to multiply top and bottom by what? I over I, essentially. So then, this becomes what? Distributing this I here, you get 3i. All right? And I times 5i is going to be what? 5i squared. But again, that means what? Negative 5 if you plug in -1 for I squared, and that changes that sign, right? Anyways, down here it's going to be what? 2I squared. 2I squared, right? Or -2. So in other words, this is going to be 3I, all right, on top, minus 5. This is minus 5 right here. Can we see that? So minus 5, all right, over what? -2. All right, 2I squared. So 2 times -1, -2. So now you should write the final answer in terms of the standard form, a plus bi. So let's write the real component first and the imaginary component. In other words, both of these numbers are being divided by -2. So let's divide the real components first. -5 over -2 is what? Positive 5 over 2. All right. What about 3I over -2? That's going to be minus 3 over 2, and my I right here. All right. So this is the final answer in terms of writing it in the a plus bi form, right, format. Okay. So, but again, the theme is what? If you're just dividing by one imaginary number, just multiply by I over I to get rid of the I on the bottom here. Right, as you can see, because we're taking advantage of the fact that I squared is what? -1 here. All right. So not too bad at all. Hopefully we can figure that out without too much difficulty. All right. Anyways, what about 2 terms on the bottom? So this sort of like the square root. We have square roots on the bottom with 2 terms, right? That we had earlier. So let's talk about that. The concept is going to be what? Timesing by the complex conjugate, though. All right. Let's try a problem like that. So let's go ahead and divide by. So let's just try 4 divided by 5 plus I. All right. Well, how do I get rid of this I, the imaginary component, the complex number on the bottom here? You're going to times to top and bottom by the complex conjugate. So let me say multiply to top and bottom by the complex conjugate. Top and bottom by the complex conjugate of the denominator, or of the bottom here, in other words, right? So focus on the bottom, all right? So here's what I mean by that. So I'm simplifying this, right? So divided by 5 plus I, 4 divided by 5 plus I. Just multiply to top and bottom then by what then? Well, what's the complex conjugate of this denominator? Well, 5 minus I. Just change that sign. Same thing to top and bottom though, right? Got to multiply the same thing to top and bottom. So let's distribute the force. 4 times 5 is going to be 20, and 4 times -I is going to be -4I. All over, well, this is of that difference of squares form, right? A plus BA minus B, where my A is 5, my B is I, so 5 squared is going to be what? 25, minus what? B squared, right? So I squared. Okay, so this will be 20 minus 4I over what? 25 plus 1, basically, because again I squared is what? -1, so 2 negatives will be +1, right, if you will. So this will be this will be 20 minus 4I. Okay, let me do that again. Sorry for the sketch pad here. 20 minus 4I over what? 26. All right. But look at these 3 numbers. They're even numbers, so they can be reduced. This fraction can be reduced. What will divide these 3 numbers? Well, how about 2? So 2 into 20 goes what? 10 times. 2 into 4 twice. Into 26, 13 times. In other words, this fraction reduces to 10 minus 2I, all right, over 13. All right. If you were to write this as an a plus bi form, it'd just be what? 10/13 minus 2 minus here 2/13 I. So that's in the standard form, a plus bi. But the theme is what? To get rid of the complex number on the bottom, or divide by it in this case, we're multiplying to top and bottom by the complex conjugate of the denominator. All right. Let's do one more to wrap things up and give you some problems to try on Blackboard here. Let's go and try this one here. Let's go and try this one. Let's go 2 minus 3I divided by 2 plus 3I. So basically, a number divided by its conjugate. How's that going to turn out? Well, again, you follow this concept, right? So we'll times to top and bottom by what? Again, by the complex conjugate of what? Of the bottom of the denominator, not the top, right? Complex conjugate of this guy down here. So it's going to be 2 minus 3I is what we are going to times by to top and bottom. by the complex conjugate of the denominator. Keep that in mind, all right? So let's work that out. Well, isn't that a perfect square formula situation? Isn't that 2 minus 3i quantity squared on top? And isn't that down here the a squared minus b squared formula where my a is 2, my b is 3i? All right, yeah, that is in fact the case. So a squared is going to be 4, all right, minus what? What's b squared? 9i squared. All right, but what's the top going to be though? Use the other formula we had earlier, right? So a squared is going to be what? 4. Here's my a, here's my b, right? So very similar to the bottom, except different formula, right? Perfect square formula. So a squared is 4. What's a times b? A times b is 6i, double it, 12i. So minus 12i, right? Minus 2ab, so that's going to be the 12i. Plus b squared. So plus what? 3i squared is going to be 9i squared. You square that. All over what? This is, again, I squared is what? Negative 1, right? So this is basically plus 9, right? So 4 plus 9 we have here, right? So this is equal to 4 minus 12i, all right? And what? Again, I squared is what? Negative 1 again, right? So this is, we're going to change that sign to minus, so minus 9. Minus 9 there. All over what? 4 and 9 is 13. Excuse me. All right, so let's go ahead. Excuse me. Let me clear my throat here. That's equal to what? 4 minus 9 combined terms, negative 5 on top, and minus 12i. All right, all over 13. Again, to write that in the standard form, that's going to be negative 5/13, right? Negative 5 divided by 13, negative 5/13, minus 12/13, right? 12 over 13, I. All right, so again, the theme is what? Multiplying to top and bottom by the complex conjugate of the denominator to simplify, to carry out the division of complex numbers, if there are two terms. Just one term, then just multiply by I over I, as we did earlier in that earlier example. All right, let's go and finish out with some problems I want you to post into Blackboard. Let's go and try these problems here. Let me go and clear off the screen. All right, let's go and post these solutions into Blackboard, if you will. Number 1, let's square out the this complex number, 5 plus 4i quantity squared. All right, use the perfect square formula to work it out, or write it twice and use the FOIL method. But again, always use the formula since it's more efficient. How about 7 minus 2i times 7 plus 2i? All right, pretty easy there. Use the difference of squares formula on that one. And 3, division here, a little bit more tricky. 3 plus 5i divided by 1 minus I. Think about the complex conjugate in this case to simplify that. All right, so post the solutions into Blackboard and we'll go over it in class. Until next time.